Good morning and welcome to part 1 of the Silica and COVID-19 Protection webinar series. My name is Paula Hyman from the Ohio LTAP Center. Before we begin today, just a couple of housekeeping items. If you have questions throughout today's presentation, I ask that you please type them into the questions box. Our presenter will address your questions periodically throughout the presentation. If everyone could now, please go ahead and locate that questions box and go ahead and just type a quick hello, hi, just to make sure that you are familiar with that and know where it's located. Great. Luke, you were first. You win the prize of being first. All right. Just want to make sure you know where that's located. Wanted to let you know that there was a pre-test that needed to be completed prior to this training series. You should have received that via email last week and again this morning. Lastly, today's presentation and handouts are available for download in the handout section. If for some reason you're unable to download the handouts, just put your email address in the questions box and I will send that out to you. Attendance verification for both days will be made, and those qualified attendees will be sent out the certificate at the end of training. I want to thank you again for your participation with that. And I'm going to go ahead and pass things off to Mr. Robinson Vasquez, the Safety Business Developer and Training Manager with the American Road and Transportation Builders Association. Robinson?
Thank you, Paula. Thank you for your help and to the Ohio LTAP for organizing this training. Welcome, everybody. My name is Robinson Vasquez. I work in the American Road and Transportation Builders Association, and we are offering this training for free with the cooperation of the Ohio LTAP, thanks to the OSHA Hardwood grant. So we got this grant to create this training and provide it to everybody in the roadway construction industry, especially. So, as I told you, my name is Robinson Vasquez, and I am originally from Peru. I am an attorney there in my country. I specialize there in labor law and construction. I came some years ago here to the US to do a master in comparative law, and then decided to do an MBA in Utah. So there in the MBA, I specialize very much on safety and productivity. What is the impact of safety on productivity in general, especially here in the US? And I discovered a great correlation between safety and productivity. As much as a company invests on safety and preventing accidents, profits are going up, productivity is going up, morale is going up, quality is going up. So there is a very good correlation here in the US because of the regulations, the laws that you have here that is helping to improve and create a better environment for our workers. So an interesting aspect about safety is this area of silica, because in this area of silica, we usually talk about safety, about fall protection, cave-in protection, electrocution, all these incidents that could happen in a second. 1-2 seconds, you have an incident, a runover, a backover. But in silica, the problem is that little by little, all this dust that we produce in the construction is absorbed in the lungs of the people, and the results are, we can see people sick with silicosis maybe 5, 10, 15 years after you have the contamination, and it is difficult to follow up and control and supervise that everybody is okay until we had this new regulation, the change in the law that is creating a very interesting system. It looks a little complex, really. When I started studying this area of silica, it looked very complex, but when you start learning how does it work, it results that it's very simple. And we are going to share with you how to understand all these silica regulations. It's not so difficult. because the new Silica rule is asking us to create a plan, in addition to the respiratory protection program, to have a Silica plan. Just some days ago, on June 25th, we have a new directive from OSHA about Silica inspections. So it was a directive for the inspectors how to do the Silica inspection. And it is interesting, it's around 150 pages. I am attaching it to all the handouts we have today. You can explore it later when we are going to talk about it a little more. And in the law, we have table 1. Okay, table 1 is something that it's attached also to your handouts. And table 1 is a great tool. You know, it's a great tool that is helping. It's going to help us to prevent incidents with Silica and also to comply with the law. Okay, so we are going to talk a little more about how to create a plan, a Silica protection plan. It's not going to be so difficult after we do the training. And at the end, tomorrow, we are going to talk a little more about COVID-19 because it's part of the respiratory protection plan. So this training is about Silica, a little about COVID. Respiratory protection plan is a bigger issue, a bigger topic. Silica protection and COVID protection is only two little parts of this big respiratory protection plan. So let me start a little more about it. We are going to have, of course, every hour we are going to have a break. During the breaks, if you have a questions, I'll be available, happy to solve your questions. And we are going to have a break to stretch or do something, 5 minutes break, and continue with the training. Okay. So, what is the objectives of this training? At the conclusion of this training, students should be able to list materials where crystalline silica may be contained, list processes and tasks that may cause silica to become airborne, describe health risks that arise from exposure to respirable silica, and demonstrate ways to perform tasks to prevent exposure to silica. So this is the objectives that we have for this silica area. Tomorrow we are going to talk about COVID-19 a little more, okay? So, but as we are doing this training, thanks to the OSHA Hardwood grant, OSHA is asking us to talk a little more also about OSHA rules and regulations. We are going to do it, but let's continue with the objectives for today. Locate OSHA's Table 1 online. Look, this one is very important. Table 1 for silica protection is the main tool that we need to use. You know, it's very easy to find it. Just Google it, browse it, OSHA Table 1, and you are going to get it. Explain how to read and interpret Table 1. We are going to learn how to do it. Relate OSHA's hierarchy of controls to typical job tasks. This OSHA hierarchy of controls is a very important tool now. That is going to, it's applicable to everything on safety, okay? But we are going to apply it to the silica protection plan. But if we can memorize the OSHA hierarchy of controls, the pyramid that we are going to show today, it's going to help you to organize much better your plan in any safety area in the work zone. Then explain the basic elements of an exposure control plan. Yep, we are going to do the plan, and we are going to learn how to do it. But as I told you, I was telling you, OSHA is asking us to share some information about OSHA, specifically how to proceed in case we have an inspection and to present any complaint before OSHA. Okay, you have this training is mainly for actually it's mainly for engineers. The level of this class is a high level because we are going to train everybody how to create a silica protection plan and how to execute this plan and how to protect the company organizations in case we have an OSHA inspection, and how to fulfill with the law also to protect our workers. So it's a little high level, but OSHA is asking us to share also this information about OSHA regulations in general. Okay, so according to OSHA, workers have a right to have a safe and healthful workplace, know about hazard chemicals, and it is important for us because we are going to talk about silica protection, and silica is a chemical. So workers should know about the silica in the materials we are using, we are working with. Then information about injuries and illnesses. So it's interesting. Let me tell you a short story. I was providing a class, an OSHA 10-hour class some years ago here in South Virginia. And when I was talking about the silica protection, I realized a lot of people, a lot of students start talking each other, very concerned. And I stopped the class and I asked them, okay, tell me what's happening. And they told me, instructor, it happens that some years ago, maybe half of the class, we were working in a quarry, and we were working with aggregates, rocks of different sizes. The company was crushing rocks, and we have all this dust around, and we didn't have any protection. Nobody told us about it. Is this dust silica? He told me. He asked me, and I said, yes, it is silica. So you are crushing rocks and producing dust. This dust has silica inside. So they were very upset and concerned about it. And they asked me, what can we do? And I told him, well, you have to make a complaint before OSHA. And maybe you need to talk with an attorney. I am an attorney, but in my country, I am not an attorney here in the US. But I know that you can create a civil action class, and they did it. So I just at the beginning of the year, we have the OSHA inspection, and they put a fine for around $300,000 to this company, and the legal process continues in another jurisdiction. But the thing is that they got the information, they start doing something about it, because they were contaminated and other people were contaminated, and the company was not protecting them against this silica dust. So yes, it's something that they were using all this information and laws to protect themselves and to protect other people. Then we have this request correction from your employer. So ask the employer, hey, there is silica here, I need protection. Information is power. So people, look, all this information, we have to, as I told you, I specialize in productivity and safety, okay? And it is interesting that big companies are very productive, and big companies are investing a lot in preventing incidents, accidents, okay? Because an accident is very expensive, not only for the worker, not only for his or her family, but also for the company. You have an incident, you call 911, everybody stop working, all the machines stop working, comes the ambulance, take the victim to the hospital, and then it depends on the nature of the incident, maybe you have an OSHA inspection, they're going to stop every activity in the area for 3-4 days sometimes, and you are losing money in addition to the medical costs. Is something else for the victim and all these things, but the company is going to lose money at the same moment. I was in Florida last year, and they had several incidents in the I-95 project they have there, and the engineers told me, only 4 days of stopping everything, every activity, it cost us around $4 million. They told me, only because they stopped working and trying to repair everything that was broken because of the accident and all these things. Then the problem is going to jump next day to the office of the company. So because the office is going to deal with an OSHA inspection, a police investigation, the insurance is going to go up next year, and you are going to have a process for around 3 or 4 years dealing with attorneys, with the problem, with the fines, and it is very expensive. Legally talking, it's expensive. Then next time you have a contract, an opportunity to have a contract, a bid, a tender, you're going to compete with other companies, and the owners, the states, government is asking you the EMR, the employment modification rate, the insurance rate, how is your safety going in your company, and according to this, they are going to allocate you some points or not. So usually now states, governments are trying to work with companies following the safety rules, because if you have a bad record, it means that you are going to have some incidents, some delays, some overhead costs and all these things, and they don't want it. They want to work with companies that are working in a safety way. Okay, so it is important, this information, because we need to talk with our workers to help us to improve safety. If safety is productivity, if we can avoid incidents, we can empower our workers and tell them, hey, whenever you have a problem with safety, please disclose it to us. We want to solve the problem inside the company. We want to solve the problems and prevent incidents, accidents. Because when workers are telling all these things to us, we are preventing incidents in the future. And also, sometimes if they are frustrated, they can call OSHA and it's going to be another problem. But the idea is to try to solve the problem inside of the company. Prevent accidents is a good business. Yeah, that's the way to go. Okay, so they also need a request correction from your employer. Please empower your workers to disclose this information to you, to your foremen, supervisors, safety directors, and take action, because you are going to not only avoid an incident, but also save money for the company in the long term. Then training about your job. They need that training. We are going to learn a little more about it, but it's important to provide training. It's in the hierarchy safety, the hierarchy controls of safety from OSHA. Then we have this other point, examine exposure and medical records. Yeah, they have the right to do it. Sometimes we need to send workers to the doctor to verify if their lungs are in good condition, and they have the right to see the result of the examination. Okay, sometimes the doctor said, no, you know that your employer is paying for this, I'm going to send it to your employer. No, that the worker has the right to see the result of the examination too. Okay, so then file an OSHA complaint. We are going to learn a little more about it, and participate in an OSHA inspection. We are going to learn more about it in this presentation. The whistleblower rights, it's something interesting. We have in OSHA these rights for the whistleblower. Somebody who realized that there is a problem, a safety problem in the company, in the organization, they have a right to present a complaint before OSHA, and sometimes there are retaliations against this person. So OSHA has created some rules to protect the whistleblower against retaliation from the company. So you may file a complaint with OSHA if your employer retaliates against you by taking unfavorable action because you engage in protected activity relating to workplace safety or health. So that's the general rule. So sometimes the retaliation can have several phases. Sometimes it's firing, demoting, denying benefits, intimidation, reducing hours, reducing pay, trading, blacklisting. But the idea is you have workers have 30 days from the day of retaliation to file a whistleblower complaint with OSHA. So it's a way in which OSHA is trying to protect the workers, because sometimes they use their right to go to OSHA and present a complaint, or sometimes during an inspection, you have workers have the right to talk with the inspector in private, or workers have the right to ask a representative to go with the inspector during all the inspection. And sometimes companies don't understand it, and they decide to create a sort of retaliation against the worker because he or she was using her rights to complain before OSHA or talk with the OSHA inspectors. Okay, so in general, we have 30 days after you know about the retaliation. Sometimes, for example, they reduce your paycheck, and you know about it just when you receive your paycheck. So you can say, hey, it's beginning from now, my 30 days, not from the day of the month, the first day of the month, but from the day you know about the retaliation. You have the 30 days to go to OSHA and present a complaint. How can you file a complaint? People can do it very easily now. We have all these electronic tools to do it. You can visit your nearest OSHA area office, but easier to do this, you can go online and find a complaint online. So it's you know, information is power. When I am doing this class with workers, I ask them, hey, do you have a cell phone? Yes. Please browse this OSHA complaint, okay? OSHA complaint, and they are going to find all the instructions how to make a complaint before OSHA. So it is going to be much easier to go online. They can get a form, they can fax and fill the form and fax it to your local area office. You can mail a letter to your local area office, or you can simply call OSHA. This is the way in which a lot of people are making complaints now. Yeah, just making a phone call. But workers need to be ready to provide all the information about the problem they are talking about. Inclusive the OSHA inspector are asking workers, did you talk with your company about this? Did you try to solve this problem with your company before? Because they don't have a lot of instructors or inspectors. I'm sorry, they don't have a lot of inspectors, and sometimes they can say, look, we are going to visit your company around 3-4 weeks, and you are trying to have a solution immediately. And sometimes talking with your foreman or asking your foreman, Mr. Foreman, maybe you don't know about it, can you please call your safety manager or safety director and try to find a solution inside of your company if you have any safety issue, okay? Because sometimes at the same moment you can find a solution. Hey, in 5 minutes you can get a solution instead of calling OSHA and starting all this process. But of course, it's the right of the OSHA, the worker to go to OSHA at any time, you know. But this is the information about how to fill a complaint. This is the form that OSHA is using to allow people to make complaints. So when we have a face-to-face training, we usually provide this form to the workers, a copy of this form to the workers to familiarize them how to make a complaint, the basic information. But the most important thing is this complaint can be anonymous. You can ask somebody else to do it for you, your pastor, your neighbor, your attorney, whoever. But you can reserve your name. You don't need to disclose your name, but it's important to get the number of your complaint so you can follow up what's happening with your complaint, the number of the file of your complaint. So anybody can do a complaint, inclusive I could make a complaint if I realize that there is a building, some workers are working in a building 20 feet high without any fall protection. So I could make a complaint. Any person could make a complaint and denounce these things to OSHA, but you have to be ready to provide all the information about how many people, what is the company name, where is located the work zone, the workplace, there was an accident before? Did you realize there was an accident before? Any near misses before? Some of this information, because the OSHA inspectors need to evaluate how urgent it is for them to visit your work zone. Maybe they can realize it's so evident that you are going to have an incident that they decide to call the company immediately and ask them to stop everything you are doing. We want to prevent an incident. We are going to visit you tomorrow. But in some cases, they can say, we are going to put in my agenda, maybe we are going to visit in 3 weeks or 4 weeks. It depends. So you have to be ready to provide all this information when you make a complaint. Especially people are, as I told you, people are doing it using just by phone and providing all this information. And OSHA is going to visit the company, the organization. So how is it when you have an OSHA inspection? Okay, I found a video that's going to help us to show it in an easy way. So let's watch this video. How can we deal with an OSHA inspection too?
OSHA's mission is to ensure the health and safety of America's workers. Enforcement plays an important role in the agency's efforts to reduce workplace injuries, illnesses, and fatalities. This video describes the general OSHA inspection process and the reasons for an inspection. OSHA conducts inspections based on imminent danger situations, worker fatalities, hospitalizations, amputations, or losses of an eye, worker complaints, referrals, targeted inspections aimed at specific high-hazard industries or individual workplaces, and follow-up inspections. Compliance safety and health officers, or compliance officers, are experienced, well-trained industrial hygienists and safety professionals. Once the compliance officer arrives on site and enters the facility, the inspection begins with the presentation of credentials. There are 3 basic parts to any OSHA inspection: the opening conference, the walk-around, and the closing conference. At the opening conference, the compliance officer will explain why OSHA is inspecting the workplace and describe the scope of the inspection, walk-around procedures, worker representation, and the need for worker interviews. The employer is asked to select a representative to accompany the compliance officer throughout the inspection. During the walk-around, the compliance officer will consult privately with individual workers. Common questions may include, how long have you worked for the company? Have you or anyone else been injured or had close calls on the job? Does the employer provide personal protective equipment? How often does the employer provide training, and what is the training composed of? Is there anything you would change to make working conditions safer? After the walk-around, the compliance officer holds a closing conference with the employer and designated representatives to discuss the findings, possible corrective procedures, and reasonable timelines for correction. The compliance officer also discusses potential courses of action an employer may take following an inspection, as well as available consultation services. Following the OSHA inspection, the compliance officer will put together a report based on what was discussed or apparent violations. The information is sent to the area director, who determines whether or not a citation is issued. If a citation is issued, the employer has 15 days to take action, such as requesting an informal conference with the area director to discuss any issues and address the penalties, or contesting the citation. A safe workplace benefits everyone. OSHA uses both enforcement and compliance assistance to achieve this shared goal. Ensuring compliance with OSHA standards is an integral part of the agency's mission to keep workers safe and healthy. That's why OSHA is working to give employers the knowledge and tools they need to comply with their obligations and provide safety information to workers. OSHA's on-site consultation program, offers no cost and confidential assistance to small and medium-sized businesses. The program helps businesses identify workplace hazards, provides advice for compliance with OSHA standards, and assists in establishing and improving safety and health programs. OSHA Training Institute education centers also offer training courses designed for workers, employers, and managers on safety and health hazard recognition and abatement at convenient locations nationwide. For more information about OSHA inspections and compliance assistance resources, please visit osha.gov or call 800-321-OSHA. That's 800-321-6742. This video and content is not a standard or regulation, and it creates no new legal obligations. The content is advisory in nature, informational in content, and is intended as a compliance assistance tool for employers in providing a safe and healthful workplace.
Okay, I just let me see if I can share it with you. This directive was published on June. It's an OSHA directive for the OSHA inspectors about how to do the inspection focusing on silica protection. Okay, it is attached to your materials, but it is a very long directive, and it is important to know about it because if we have an OSHA inspection, these are the questions, the procedure that the inspectors are going to follow up to do the inspection. And some of the questions that they are going to ask is, for example, they can go to a worker and ask him, hey, who is your silica protection competent person? Have you received training about silica protection? Did you receive the right personal protective equipment for your job, and so on? So this is important to know what is going to happen during the inspection. We watched this video, is a general idea about the OSHA inspection, but there are particular information, specific information about silica. Similar to other inspections, they are going to ask you also to show a silica protection plan. It is in the law. So all these things we are going to discuss a little more during this presentation. Okay. So we were talking about the OSHA inspection, the OSHA, the whistleblower protection against retaliation. We learned a little about OSHA processes or inspection process, and we are going to start talking about the specific topic about silica protection. Okay, how does silica affect your body? So when we are doing our regular classes, we ask people, hey, how can it affect your body? We are talking about silica, this dust that we produce when we are manipulating rock, sand, bricks, cement, concrete, different materials. Basically, almost everything in construction that is not wood, that it's not metal, that is not plastic. All the other materials have silica inside in different percentages, but we have this silica, and every time we are manipulating it, it's possible for us to produce this dust, and we don't want this dust to go inside of the lungs of our workers. So it usually, silica is going to affect usually workers in the long term. So 10 years, 15 years after you have the exposure, people can have all the illnesses related with silica. So maybe you know any cases where a worker had died of gotten sick as a result of silica exposures. Sometimes I ask people, do you have this experience? And people say, yes, my aunt, my uncle had this silica, and they have to go everywhere with oxygen, and he cannot do any other activity because his lungs were full of this silicosis, these illnesses. So health hazard of silica, you can identify some health hazards. Silicosis, people can get lung cancer also. They can get chronic obstructive pulmonary disease, kidney diseases also, autoimmune diseases. So the problem is this dust going inside of our lungs, and our lungs are going to be the main organ affected inside of our bodies, and also our kidneys, because we are talking about this dust, and sometimes it can be in our blood, and our kidneys are going to filter it, and they are going to accumulate all this dust and create some rocks inside, so we can have rocks in our kidneys and all these things. So we have a very good video that is going to help us to understand what is silica, what is the problem with this dust in a very didactic way. So let's watch this video.
Silica. It's one of the most common substances on Earth. It can be found in materials like sand and rock, and building products like concrete and brick. When a worker cuts, grinds, or drills materials that contain silica, dangerous crystalline silica dust is released into the air. As the worker breathes, silica crystals flow into his mouth and nose and down the air passages deep into the lungs. The tiny crystals enter the small, fragile air sacs, where oxygen is absorbed into the blood. Immune system cells, called macrophages, engulf and try to dissolve the crystals, but they are unable to. Over time, more and more crystals build up inside the macrophage cells. The macrophages carry the silica into the walls of the lung, where they die. Scar tissue forms around the dead cells and spreads as more cells die. This damage can continue even after the exposure to silica stops. Eventually, so much scar tissue forms that the lungs can no longer function. For information on how to protect yourself from silica exposure, visit worksafebc.com.
So the big problem is silica is microscopic, but we are talking about millions of these microscopic particles accumulating in your lungs, and they are not going to leave our lungs. They are going to stay inside, and they are going to create so many microscopic scars that it's going to prevent your lung to expand and contract as usual, and you are not going to be able to absorb the oxygen and interchange with the CO2 in your body. Yeah, it is something that is going to kill people little by little. Not only kill people, but also prevent people from working. So people affected by silicosis, silica, lung cancer, they cannot work because they cannot move practically, because they don't have oxygen enough to do any activity. So we are going to watch another video related about the story of the silica protection in general, and how did we arrive to our current regulation in OSHA. But it's interesting that people knew about the problems with silica for centuries, and we didn't have any specific norm or standard to protect our workers. Just in 2016, we have a effective standard that is making mandatory to provide some protection that we are going to learn in this class, provide some protection for our workers to prevent silica, silicosis, and all these illnesses related with silica. So this is the video I was talking about. It was produced, created by OSHA by itself, but it's going to help us to understand what was the process to create this current regulation.
Hello, everybody. I'd like to describe a historic occupational health disaster that significantly affected workplace safety and health regulations. It's a story of silicosis at the Hawks Nest Tunnel near Gawley Bridge, West Virginia, and the time is the late 1920s. West Virginia is absolutely beautiful. Rolling mountains, fast-moving streams, and great windy back roads for motorcycling. But at the industrial level, the images are of chemical plants, coal mines, and mining disasters. But this story is not about chemicals or coal, but about workers drilling a 3-mile tunnel to expedite water flow for hydroelectric power. Gawley Bridge is where two important rivers, the New River and the Gawley River, converge and become the Kanawha River, the lifeline of West Virginia. The Kanawha ultimately flows into the Ohio, Missouri, and finally the Mississippi, so it's an important transportation vehicle for coal and chemicals. Drilling a tunnel through Hawks Nest Mountain was especially dangerous due to its high crystalline silica levels. This, together with a poorly ventilated work area and no worker protection, produced a formula for disaster. This government video describes some of the problems.
In the 1930s, hundreds of men were hired to dig the Gawley Bridge Tunnel in West Virginia. They too were ignorant of the risks they ran. Desperate for jobs during the Depression, they worked with virtually no protection in a tunnel filled with silica dust. 476 men died here from silicosis.
My name is Walter Kincaid. I work in the tunnel 4 or 5 weeks. Every day I hear of someone die with silicosis.
You can imagine the high levels of dust in a tunnel like this. While many quote the number 476 that died, it's likely that hundreds more died years later. About 75% of the 1,500 miners recruited to drill the tunnel were African Americans, brought in from the Deep South as non-union workers. The workplace disaster at Gawley Bridge is especially poignant in African American history. Of course, you know silica or silicon dioxide as sand. Approximately 12% of the Earth's crust is made of silica. So how can this be so toxic? Well, silica is complicated. Depending on how it was formed in nature, it can either be amorphous or crystalline. The toxic form of silica is crystalline silica. You probably heard of the most common form called quartz, but there are others, namely cristobalite and tridymite. These three are all associated with what's called silicosis, a fibrotic disease of the lung. However, crystalline silica is also a confirmed human carcinogen causing lung cancer. Concrete is a mixture of sand, rock, and the binder of cement. There are many crystalline silica. There may be some crystalline silica in the sand or rocks used for concrete. And when this is ground, chiseled, or drilled into, a fine dust will be generated. What's common in many areas is grinding down sidewalks to remove a tripping hazard. I've seen many of these operations, and they all create large amounts of respirable dust. Wet methods or vacuums should be used to protect workers, but often a flimsy paper respirator is used, and sometimes nothing at all. This is especially true of small-scale construction companies. Walk the streets in any city, and you'll see workers grinding, drilling, cutting concrete, granite, stone, or cinder blocks. This doesn't mean they're exposed to dangerous levels of crystalline silica. Exposure is a function of percent quartz in the stone or concrete and the particle size being generated. So while these images may seem risky, it's possible there is little or no crystalline silica in the air. But the workers at the Hawks Nest Tunnel near Gawley Bridge, West Virginia, weren't so lucky. They were drilling into very high quartz-containing rock and suffered the health effects. So when you're visiting beautiful West Virginia, stop by this area and visit the memorial for the hundreds of workers that perished in one of the most deadliest workplace poisonings in U.S. history. Thanks for listening. Goodbye.
I'm going to there is another video I want to show you. I'm going to show you later about the process of the creation of the law. But at this moment, we know a little more about where can we find silica, how can it affect our lungs, and you have here a comparison between a healthy lung with one with silicosis. So it is real. People don't realize sometimes how bad is this, because the effect of the silicosis contamination, you can see it in 10 years, 15 years, and sometimes people cannot relate it with the job activity they were doing some years ago. So sometimes it's difficult to identify what is the cause of the silicosis, and you can find it difficult to create a legal case to prove that you were working in a place exposed to silica and these guys are responsible for your illness. So, but some symptoms of lung disease, you can have it here. Sometimes there are no symptoms in the early stages of the disease. Of course, then later you can have coughing and shortness of breath, fever, weight loss, exhaustion, and coughing up blood. So because it's affecting your lungs. Okay, so but as I told you, in general, people cannot survive without an oxygen cylinder going everywhere with this oxygen. They can not work, they cannot do anything because they don't have enough oxygen to move their body, and they are there. So waiting for that time to die, because it doesn't stop. Silicosis continues growing and growing. Inclusive after years you stop the exposure, you continue having silicosis and it continues affecting your body, and the scars continue expanding in your lungs. So it's calculated that over 500 construction workers are believed to die from exposure to silica dust every year. So we are talking about a big number, really, for construction in general. But the problem is that sometimes workers cannot identify where or what activity or when, or the company that didn't protect them, and they cannot make a legal claim. It's difficult sometimes to identify where did it happen, the contamination, or maybe the worker was working in several companies, in several construction companies, and it is difficult to say in which one you have the contamination, or maybe you have the contamination in all of them. But now we have a rule that it's making it mandatory for the employer to provide effective protection. If not, they can be subject to the fines from OSHA. Actually, this year 2020, OSHA said that they were going to focus very much on silica protection. It happened before the COVID-19 pandemic we have now, but they have the plan to focus very, very much on silica protection. So we have here a comparison of the level of exposure, permissive level of exposure. We are going to talk more about it, but you can compare the exposure of silica to a person. You can read here the largest amount of silica someone should be breathing in a day after using the right controls is shown next to the penny. Okay, but you can see this is a small amount of silica, but little by little it's accumulating in your lungs, and we don't want it. Nobody wants it. Okay, so we need to learn how to prevent it, how to protect our workers. We have some sources here. Let me continue with the next module. So we are going to learn a little more about where can we find silica, and what materials can we find silica, and what is the effect on our bodies. So OSHA has created this good video. This video is more about respiratory protection in general, but we need to apply the sections also for the silica protection plan.
Crystalline silica is one of Earth's most common minerals. It is found in stone, brick, rock, concrete, block, mortar, asphalt, and sand. Using power tools on these materials for tasks such as cutting or grinding can release tiny particles of silica into the air. These tiny particles are known as respirable crystalline silica. Workers who breathe in respirable crystalline silica can develop diseases that can be life-altering or deadly.
Traditionally, on construction sites, silica with grinding and cutting produces a lot of dust to the workers' lungs.
Exposure to respirable crystalline silica can cause silicosis, a disease that permanently scars the lungs. It can also cause lung cancer, kidney disease, or chronic obstructive pulmonary disease, also known as COPD. The chances of developing these diseases increase with higher and longer durations of exposure.
What we're looking at on the left is a normal lung. You can see that the lung tissue on either side of the heart is dark and black, and that means it's full of air. And the X-ray on the right, you can see those white scars throughout the lungs on both sides. That's all scar tissue. Is from a patient with advanced silicosis.
Without protection, workers who are exposed to very high levels of respirable crystalline silica during activities such as abrasive blasting with sand can develop silicosis within a period of months to a few years. Workers usually do not develop signs of silicosis until after they have been exposed for 10 years or more. Once silicosis symptoms, such as shortness of breath, appear, the symptoms can get worse over time, even after the worker stops working with silica.
Usually people who develop silicosis have been very healthy, vigorous people, and they find after years of the disease that they're short of breath, that they can't go very far, they can't walk very far, they can't climb the stairs. They may even be short of breath just sitting still. I continue to see new cases of silicosis, and yet there is still no treatment. So I would like to see prevention of silicosis so that this disease is eliminated from our hospitals and our health clinics.
Silica disease can be prevented by controlling exposure to silica dust. Water can be used to wet the dust and prevent it from getting into the air. Vacuums can be used to remove the dust at the point where it is made.
We store up a lot of dust, so we try to prevent as much of it getting in the air as possible. So we use these vacuums. While we're working on cutting the joints out, we create a lot of dust, which we collect in the vacuum inside these bags. I'd much rather have it in this bag than I would inside my lungs.
Once I tried the new things, it worked well. Because at the end of the day, I went home without silica dust in my lungs. I went home clean at the end of the day, and I got used to it.
Gary Stassy's family business is stone carving. His father and his grandfather both died of silicosis.
I believe that our industry here has worked hard to bring in new technology that does help with the silicosis problem. I also believe that there's also room for more education for the workers themselves to understand the critical reasons why they have to be very careful in this industry.
In today's climate, we stress to our customers safety, financial stability, company stability. We remind our men we want them to go home same shape or better shape than when they showed up at work that morning.
OSHA's rule for respirable crystalline silica requires employers to protect workers from silica dust to prevent them from developing disease. Silica-related diseases can be prevented if proper controls are used to reduce workers' exposure to dust. More information on OSHA's requirements to protect workers exposed to respirable crystalline silica can be found at www.osha.gov/silica. For information about other OSHA health and safety standards, go to www.osha.gov or call 1-800-321-OSHA.
So how can we determine if silica is present in the workplace? Consider your industry, occupation, and materials. So we are going to start learning about all these areas in which it depends. How can we find silica in our workplace? It depends on what you're doing, what materials you're working with, what kind of industry you are working in. So how construction workers are exposed to silica? If you do these activities, abrasive blasting, asphalt pavement manufacturing, remember pavement in general is 96% rock, only 4% is tar or bitumen. Cement manufacturing, concrete mixing, concrete tunneling, road construction, demolition, tunneling operations, workers in general working in mountains, building a new highway or roadway, usually have to open the area not only for tunneling, but also opening the area in mountains, in areas in which you have to cut rock, you are exposed to silica, jackhammer operations, masonry, and many more. So respirable silica may be present. This dust is the problem. Sometimes people ask me, hey, is the sand hazardous for us? If I go to the beach, I'm going to be contaminated with silica? The answer is no, because the grains of sand are gigantic. It's very big compared with the silica dust. The silica dust is microscopic. You cannot see a particle of silica dust, but you can see all the dust floating in the air. This is silica. Okay, so sand cannot float on the air, but the dust that is floating in the air, if you start crushing sand, you can produce silica crushing sand or crystalline silica by crushing dust, or doing all these activities. Abrasive blasting, asphalt, cement, concrete, tunneling, road construction. You are drilling, you are using a jackhammer, you are crushing rock, or using a saw to cut the pavement or the concrete, you are producing silica at that moment. So common activities in road construction that can have silica exposure: drilling, cutting, grinding, shipping, or hammering concrete, stone, or masonry, using abrasive sandblasting, crushing rock and concrete, mixing concrete. We are producing dust, and we don't want to breathe this dust. We want to prevent people to breathing this dust. So common activities in roadway construction that can have silica exposure: loading, dumping, and hauling rock and concrete. You have this dust. If you can see the dust floating in the air, that's the problem. Again, tunneling operation, miling concrete and asphalt, dry sweeping, or using compressed air to move dust, sand, or rock. The other day, somebody was asking me, hey, we are going to sweeping or cleaning the area from dust. Is it something that is prohibited by OSHA? And yes, it is prohibited by OSHA. OSHA doesn't want to see dust floating in a roadway or any construction area, because most of this floating dust is silica. So they want us to use other methods to control. In the video that we watched previously, we saw two methods: just using spray water to contain the dust on the soil, or using a vacuum to absorb all the dust. But the idea is, the objective, the goal is to prevent this dust to float on the air, to be airborne. So it depends also the occupation. What do you do? Workers that have these occupations are at risk of silica exposure: construction laborer, road construction, transportation, homes, etc., crushing and grinding machines operator, mining machine operator, rock driller, sandblaster, material moving equipment operator. So these occupations are exposed to silica, but we need to think about the other people around these workers. Okay, these guys can be working directly with silica. Maybe they have all the protection, the personal protection equipment, but what about the other workers that are working around, but they are not protected, that they can breathe all this dust? Other examples about materials containing silica, you have here asphalt, rock, stone, tile, brick, sand. Practically everything that is not wood or is not plastic or metal has silica. It's my doing my final conclusion about it. Almost everything is silica, except wood, except plastic, except metal parts. So ways to determine if a material contains silica: check the label. There is an obligation for the manufacturer to provide us the label indicating if there is silica inside of a product. Check the safety data sheet. There is an obligation for the manufacturer or person selling all these materials to give us a safety data sheet. We're going to talk more about it. Review the published data, so to know what materials have silica and what is the percentage of silica in a material, and sending some samples to the lab to be analyzed. So these are the way to determine at the end how, not only if it has silica, but what is the percentage of silica you can find in some construction materials. There may be materials and tasks where silica is present. However, exposure is anticipated to be below the action level of 25 micrograms per cubic meters of air. So this is interesting because OSHA says, you know, you have to start doing an analysis of the environment. If it has more than 25 micrograms per cubic meter of air of silica, you need to follow the law and protect your workers. If it is less than 25 micrograms, you are okay. You don't need to follow any plan or do anything because you don't have enough silica in your environment. We are going to talk a little more about it. Some examples of these activities: mining concrete for post holes. We don't produce a lot of dust, practically nothing. Pouring concrete footers, slab foundations, and foundation walls, and removing concrete from work. We cannot see any dust when we do these activities, and they are considered to be below 25 micrograms. With this also called the action level. The technical name of this 25 micrograms per cubic meter of air is the action level, is the technical name. So there is a potential for danger when crystalline silica particles are in the air. So that's the thing. But also it is important to know that there may be silica particles in the air even though you don't see any dust. So it is possible to have silica. The main indicator, if you can see the dust airborne in the air, you have silica there. But it is possible to have silica if you cannot see it. Yes, it is also possible, but usually the levels are low. But it's something that we are going to discuss during this presentation. When do we need, or where and when do we need to follow the silica rules from OSHA? So it is 11:02. It's time to for a break, but Paula is going to send you a poll now. So Paula, I'm ready for your poll.
All right, everyone. The poll is up. Poll question is up. And if you were in full screen, just hit the escape button in order to be able to vote if you were in full screen. Question reads, per the CDC, what is the minimum distance that must be maintained when social distancing to prevent the transmission of COVID-19? Please select one answer.
So we are going to talk about it tomorrow. It's just a poll in general to know what do you know about this silica or the COVID-19 problem, and to verify that you are here with us today. So we need to show that you were here with us, to our grantors, for example.
All right, we have about 87% who voted. Right now, I'll go ahead and give you another few seconds here. And please don't answer in the questions pod. Please answer on the screen. If you are unable to make a selection, hit the escape button first, and it should allow you to vote on screen. All right, Robinson, we have 90%, and I'll share the responses right now. 6 feet, 100% of the voters chose 6 feet.
Great. Yes, that is the right answer. And yes, so we are going to have a break. I have 11:03 now here in Virginia. Let's continue at 11:10, okay? Wherever you are, just calculate wherever you are, have 10 minutes. So 11:10 is our time to continue with the training. So I'm going to find this video I promised before. Do we have any questions at this moment, Paula?
There are no questions in the questions pod.
Okay, but you can ask your questions at any time. So at the end of this presentation, I could answer them. Okay, thank you so much. See you in some minutes. Okay. Are we ready, Paula?
We're ready.
Okay. Apparently, OSHA has removed the video that I offered you to show about the process of the creation of the current standards of silica. But I think I have a copy somewhere. I'm going to find it to you for you and show it to you tomorrow. But let's continue with our presentation. So we were talking about where can we find silica, and we need to follow the global harmonized system. You know, some years ago, the U.S. subscribed an international agreement to share the same way in which we register all the information about our levels and our material, what we used to call material safety data sheet. Now it's just safety data sheet. So we agree with other countries to have this leveling system in which we are using pictograms and providing the information. For example, this pictogram we watch here is telling us, hey, there is a silica hazard in the area. So the idea is that people in China, Russia, Germany, they can see this pictogram and they need to be trained to recognize, hey, the meaning of this pictogram. So they don't need to read the language or learn another foreign language, but they can read these pictograms because they are universal. So it's an obligation of the manufacturer to give you or provide you any materials with the level, the right level, indicating what chemicals you can find inside. Okay, so they are going to, there is, for example, manufacturer's responsibility, attach a label to all products that contain more than 0.1% of silica that may be hazardous when used. So that's the obligation. If you have more than this level, you have to provide this information to the workers. And the responsibility of the employer is to ensure that the level is not removed or defaced. So the idea is also to train your workers about how to identify what materials have silica and what activities can produce silica too. So then the manufacturers need to give you a safety data sheet. We used to call it material safety data sheet some years ago. Now it's just safety data sheet. But the important thing in the material or the safety data sheet is that there is an order now, okay, in which this is mandatory for every manufacturer to follow this order, because before we have this harmonized, global harmonized system about chemicals, manufacturers can have or create a material safety data sheet and put information in the order they want. But now we have this order, and it's mandatory because it's easier for everybody to understand a safety data sheet with information about how to, what is the risk of exposure of some materials, what to do if there is you know, a spillage of some materials, some chemicals, how to clean the materials. And sometimes we don't have this information in the level because the level is small. But we have the safety data sheet in which we have maybe 8-10 pages giving us the information about the chemical inside and what to do if case we have any exposure, or how to prevent exposure, or what requirements do we need to follow to prevent an exposure. So it's the information is provided by the manufacturer too. It's mandatory. If you have silica more than 0.1% of silica in a product, the manufacturer has the obligation to give you that level and also the safety data sheet. Okay. Then how else can we find silica? Review the published data. You know, there are organizations providing information, or sometimes some reviews, some magazines, some scientific studies, some researchers in which we can find information about what is the percentage of silica in any product. So for example, we have this chart here, this table here showing us the percentage of silica in some products that we usually use in construction: brick, calcium silicate bricks, concrete cement mortar, aggregating concrete, fiber cement sheets, tile, grindstone, gritstone, and so on. So all these materials you have here, you have the percentage of silica. So another way to know if you have silica in some materials is to send it to the lab. So you have you can hire a laboratory to do the analysis. Okay, there are some special indications from the American Industrial Hygiene Accreditation Laboratory Programs website, in which they include a list of accredited laboratories that you can go. So you can visit this web page. You can request information about the labs doing silica or testing about silica, and they are going to provide you the labs in the US in which you can test your materials. Okay, then in miningusa.com, it includes a list of consultants and the type of testing services provided by each company. So sometimes you need to cut a mountain, or you need to do a tunnel in a mountain, and you need to know what material, what kind of rock do we have here. In the Hot Nest disaster, for example, almost all the rock there was full of quartz, silica, and it is the reason why people died in the same day of the exposure. They were dying in the same day, in the same place. They are not waiting for, or the illness was not waiting for a year or 10 years to appear. No, it appeared immediately the same day, and people were dying. So it's important to analyze these materials to know what kind of materials are you working with. So these are some questions that we can ask to the laboratory to know if they are going to work pretty well with you and your samples. Does your company participate in the American Industrial Hygiene Association Industrial Hygiene Laboratory Accreditation Program? Does your company have experience working with construction contractors? Who will collect the samples? Sometimes the company, or sometimes you have to collect the samples. What is the cost of conducting a sample, and what does it cover? Are you equipped to analyze bulk samples of materials for their silica content? If yes, how much experience does your staff have analyzing crystalline silica? What sampling methods does your laboratory use? Does this method comply with accepted government requirements? If yes, which ones? Will I receive a written report? Will there be a non-technical explanation? And these questions are important, especially about the non-technical explanation, because sometimes you can receive a written report, but you cannot read it because you don't have the technical knowledge to read it. Sometimes you go to a lab to take a blood test, and you receive a paper with some information, but you are not a doctor to understand it. It's similar to this case. So it's important to get some information, some non-technical explanation, to just know how much silica do we have, and if possible to know what methods do they recommend to us to control the silica exposure when we are working with these materials. So some additional silica resources, and this is interesting. You can go and visit this web page, CPWR. They have very good materials about silica. They have a software in which you can complete the answers, and automatically the software is going to create you a silica protection plan. Or you can find additional information about materials and the percentage of silica what percentage do they have of silica. And also we are going to talk about table 1. In table 1, you are going to find 18 different activities in which you can produce silica and how to protect you. But also there are many other activities that are not included in table 1. So CPWR has in its web page some additional information about other activities not included in table 1, and how can you work, what can you do to prevent silica exposure for your workers. So not everything is in table 1. Table 1 is just working with these most frequent activities producing silica, but additional information of other activities, you can go to CPWR and find these additional activities. So some sources, you can read some sources. You can, if you want to do additional research, you can visit these web pages and find additional information. Okay, so we are going to continue with the next module. Okay. So how can we control workers' exposure to silica? And now it's important, if you have table 1, you can, I recommend everybody to print it because it is going to give us solutions, practical solutions to fulfill with the law. Be sure that we are not going to have any fine from OSHA if we have an inspection. The table 1 is very important, but we are going to learn all the methods that table 1 is recommending us to follow to prevent the exposure to silica. And we are going to start with this hierarchy of controls. Okay, this is a universal tool that OSHA has created to control any hazard. So OSHA recommends us, if we are going to start working in any project, they recommend us to start with a hazard analysis. Okay, go to the place and start identifying all the hazards you can find in this location. Maybe you are going to work near some power lines, so you have electrocution hazards. Maybe you are going to do some excavation and trenching. You have maybe caving hazards, or you are going to work in high altitude. You need fall protection hazards. So you identify all your hazards, and then you need to think about how are you going to control this hazard? How can you keep your people safe? And the first line of protection is elimination. Okay, how can I eliminate the hazard, completely the hazard? Talking about some examples, for we can, in this case, for example, talking about silica. If you are thinking about building a house, maybe you can decide to build a house using just wood or timber. And in that way, you can prevent working with silica materials containing silica, you know, rock, bricks, mortar, tiles, cement. If you decide to build all your house with only wood, that could be a way, for example. Substitution. Substitution is talking about maybe using some products or some methods to prevent the production of silica dust. For example, when you are doing some blasting operation, you want to polish some metal and eliminate all the paint, you are using some blasting. You can substitute the sand for another material to produce the same result. So you know sand. If you start doing sand blasting, you can produce this dust. We watched some videos before about people doing sand blasting, and if we can eliminate the sand or the silica using other products, that could be much better. Then we have engineer controls, and OSHA is focusing very much on these two areas, and those three areas practically: engineer control, administrative control, and personal protective equipment. All the methods that you're going to read in table 1 to control silica are related with these areas: engineer, administrative, and personal protective equipment. But just remember, it's most effective to think about how to eliminate the hazard, how to substitute, create a source of substitution to eliminate the hazard, and then you can apply all these methods. And this order is from most effective to least effective. Personal protective equipment is usually related with safety, but you can realize, according to this chart, is the less effective, but this is also mandatory in some cases. Okay. Talking about substitution, for example, you need to buy a new jackhammer. Maybe you can buy a jackhammer that allows you to use some water spray system to the point of contact to control the dust. Maybe it's going to be a little more expensive, but it is a way in which you can work to prevent more contamination for your workers and fulfill with the law, by the way. So we are going to learn about engineer controls very much here. What kind of engineer controls, especially OSHA is talking about spraying water in the point of contact to prevent the dust to airborne. Use a vacuum to absorb all the dust, and also isolate the worker. Isolate the worker from maybe an operator in a cabin in which he can work with a filter, air conditioning, or heating, cooling system, but isolated from the dust. So this is the methods that we are going to study. Administrative controls also. You can train your workers to identify the hazard, the silica hazard. You can create areas only for authorized personnel, so you can prevent workers who are not authorized to work in an area to go into this area, because you can have silica there, and so only people who are trained about silica can work in this area. And then you can rotate your workers. And it's something that OSHA is going to allow us to do. In some cases, workers don't need to use any personal protective equipment, but if they are working more than 4 hours, it is suggested to use, or it is required to use a mask, an N95 mask, a protection of 10. We are going to learn a little more about these things. But some people decide, hey, we are going to rotate our workers to avoid them to go to 4 hours, so they don't need to use a mask. We are going to rotate workers every 3 hours. In this way, they don't need to use a mask. So it's an alternative. Then personal protective equipment, we are going to learn a little more what are the requirements. When do we need to use masks, N95 masks, for example. In some cases, it's not required. If we are fulfilling with the law, using all these engineer control methods, administrative control methods, in some cases, we don't need to use a mask when we are working. So this is the methods that we are going to use in this presentation, and OSHA is using for the table 1. Then all employers must protect employees from being exposed to unsafe level of silica. You can go to your book to 1926, 1153, and find the standard. So this pyramid shows OSHA's hierarchical control in order to their effectiveness, okay? It's better to think about how to eliminate, substitute, engineer control, administrative control, and PPE in that order. So we should prefer the most effective to the less effective, but in some cases, the less effective are mandatories too. So what engineer controls can we have from OSHA in table 1? They give us 3 different controls methods. Using wet methods, spraying water to prevent the airborne of the silica dust. Using vacuum dust control systems, an aspirator, a vacuum absorbing all the dust, or isolation. So we have these 3 alternatives in table 1. The wet methods involve the use of water or foam to keep dust down out of the air. So we can see this saw is attached to a system providing water to the point of contact and preventing all this dust to airborne. It is another, it's not very clear here, but this is a jackhammer, and another worker is spraying water to the point of contact to prevent the dust to airborne. It's another method that we can use. But the idea is water is going to prevent this dust to airborne, okay? So wet methods, water spray systems, tools that have an integrated spray nozzle aimed at the tip of tool can lower silica exposure. You can see here this jackhammer is attached to a system in which they provide water spraying to the point of contact. So it's something that is going to help us to prevent the silica contamination. But there is another problem when we are using water. What are we going to do with all this slurry formed as a result of using water? So the idea here is we don't want this slurry, because when it dries, it is dust again. And if somebody is walking in the area, a machine is passing through the area, or somebody is sweeping the area, all this dust is going to airborne again, and we don't want it. So OSHA is asking us, to control, to process this slurry and prevent it to be dry and become airborne. So we are going to watch here a video about this engineer control method applied to tasks. So they're going to focus very much on this spray water method.
The Occupational Safety and Health Administration requires employers to limit workers' exposure to respirable crystalline silica on the job. This is one of a series of videos showing dust control methods that OSHA specifies for many common construction tasks in Table 1.
I want to stop for a while here because they are now using Table 1. Okay, in Table 1 there are 18 different activities. One of these activities is this one, handheld power saw. So they are going to, in this video, they are going to explain how to fulfill with the law using Table 1. Okay, and when do we need or where do we need to use a mask to protect our workers? So it is an example of the application of Table 1 to the work zone, especially when we are working with power saws.
And at the respirable crystalline silica standard for construction. When used properly, these methods are effective in limiting workers' exposure to respirable crystalline silica dust. This video describes how to fully and properly use an integrated water delivery system to control dust when using a handheld power saw to cut materials that contain crystalline silica. Many handheld power saws have a built-in water delivery system that applies water to the saw blade. The water reduces wear of the blade and prevents the blade from overheating. Applying water to the blade can also effectively control dust when cutting material containing crystalline silica. To comply with Table 1, the water delivery system must be integrated with the saw and must continuously feed water to the blade. An integrated water delivery system is one that was supplied by the equipment manufacturer and developed to be used with the specific make and model of the tool. An integrated water delivery system for a handheld power saw typically consists of a water source, connectors, hose, and nozzle. The water source can be a pressurized tank or a hose connected to a faucet. Some handheld power saws have an integrated water pump. It's important to correctly operate and maintain the water delivery system. When the water delivery system is not working properly, dust is not effectively controlled. With regular use, debris can clog the pump, hoses can become pinched, and hose connections may fail. When applying water to the blade, the operator should also make sure that the amount of water is sufficient to minimize release of visible dust. To make sure a continuous stream of water reaches the blade, the saw operator should regularly check nozzles for damage, check water pressure, remove any clogs, and ensure that the hoses and connections are intact and working correctly. When using a portable water supply, the saw operator should make sure, before starting to cut, that enough water for the saw is available to apply a steady stream to the saw blade while cutting. The saw must also be operated and maintained according to the manufacturer's instructions to minimize dust emissions. Instructions often specify the following: the type and diameter of the blade, the recommended amount of water to apply to the blade, procedures for checking the blade for wear or damage, and a maintenance schedule. Any slurry produced should be cleaned up to prevent the slurry from drying and releasing silica dust into the air. As long as the integrated water delivery system is fully and properly implemented on the handheld power saw and the task is performed outdoors for 4 hours or less during a shift, the saw operator and workers who are assisting the saw operator are not required to wear respirators. If the task is performed outdoors for more than 4 hours during a shift, or indoors, or in an enclosed area for any length of time, the saw operator and workers assisting the saw operator must use respirators with an assigned protection factor of at least 10. When respirators are required, they must be put on before beginning the task and must be worn the entire time the task is performed. When respirators are used, the employer must comply with OSHA's respiratory protection standard. Using a handheld power saw indoors or in an enclosed area requires an exhaust method, such as a portable fan, as needed to minimize the accumulation of visible airborne dust. Be sure that any exhaust method chosen moves airborne dust away from workers and does not block an exit route. Employers who fully and properly implement the dust control methods specified by OSHA in Table 1 are not required to measure the saw operator's exposure to respirable crystalline silica or the exposure of other workers assisting with the task. The respirable crystalline silica standard for construction also includes additional requirements to protect workers exposed to respirable crystalline silica. Many of these requirements apply whether employers are using a dust control method specified by OSHA in Table 1 or an alternative dust control method. More information on the standard's requirements to protect workers exposed to respirable crystalline silica, including information on specified exposure control methods for other common construction tasks, can be found at www.osha.gov/silica. For information about other OSHA health and safety standards, visit www.osha.gov or call OSHA at 1-800-321-OSHA.
So we learned a little more about one of the methods that we can use to control, and one of the engineer controls that we can use is the spraying. Now we are going to learn a little more about the other method, engineer control method that we can use using vacuum dust collection systems. So these vacuums are going to remove dust at the point where it is made. A dust collection system can significantly reduce the amount of dust in the air. Yes, of course. And that's why OSHA is recommending us to use it in some cases. So when these vacuums, we keep the vacuum hose clear and free of debris, kinks, and tight vents. We don't want to obstruct or affect these hoses, or if it has some blocking areas, some punctures, some of the dust can escape from these punctures. So we want to verify that the hose is in good condition. So they are asking us to change vacuum collection bags as needed, or at least as often as the manufacturer recommends. Do not overfill the bag. So we need to verify constantly that the collection bags are in good level. Also the filters can be clogged because of the dust. We need to follow some procedures to manipulate the vacuum collection bags and also to clean the filters. So we are going to talk a little more about it here. For example, what are we doing wrong here? We are cleaning the filter, but as you can realize, all the dust is airborne, it's on the air, and that's something that we don't want, okay? Because people can start breathing all this dust, and we don't want it. So the recommendation, OSHA is giving us some recommendations about how to do these procedures. For example, they say set a regular schedule for maintenance and filters cleaning of the vacuums. Avoid exposures to dust when changing vacuum bags and cleaning or replacing air filters. Place filters into sealed bags to prevent releasing silica dust. Change, discard, or clean filters per manufacturer recommendation. So the thing is, for example, if we are cleaning or manipulating all the bags or all the filters, we have to do it inside of the bag. Put it inside of the bag and start cleaning it in a way in which all the dust is going to be contained inside of the bag, because we don't want it to be dispersed in the air. How to dispose of the dust collected in the filters and vacuums. So slurry generated by wet methods should be cleaned up before it dries using a wet vacuum. When emptying the vacuum, the slurry will be transferred into a plastic bag and placed inside of a container for disposal. The container will be sealed to prevent the release of dust back into the workspace. Never sweep or use compressed air on dried slurry If the slurry dries, immediately wet it down and clean it up with the wet vacuum. So the idea is OSHA doesn't like any dust airborne in the air. So we have to prevent whatever we are doing. We have to follow some methods to prevent this silica dust to airborne. So it's an OSHA violation. I have here a video in which we are going to learn more about vacuums, the engineer vacuum control system. So this one is again used in table 1. Okay, they are going to select one activity in table 1, and they are going to use and follow up the instruction in table 1.
Occupational Safety and Health Administration requires employers to limit workers' exposure to respirable crystalline silica on the job. This is one of a series of videos showing dust control methods that OSHA specifies for many common construction tasks in Table 1 of the Respirable Crystalline Silica Standard for construction. When used properly, these methods are effective in limiting workers' exposure to respirable crystalline silica dust. This video describes how to fully and properly use a commercially available shroud and a dust collection system to control dust when using a handheld grinder to remove mortar that contains crystalline silica. The process of removing and replacing mortar is commonly called tuck pointing. A shroud and dust collection system can control dust created by handheld grinders used for tuck pointing. Commercially produced shrouds and dust collection systems are readily available for use with handheld grinders. To comply with Table 1, the dust collector must provide a minimum airflow of 25 cubic feet per minute for each inch of wheel diameter. For example, if a grinding wheel is 4 inches in diameter, then the dust collector must provide at least 100 cubic feet of airflow per minute. The dust collector must also have a filter with 99% or greater efficiency and a cyclonic pre-separator or filter cleaning mechanism. Cyclonic pre-separators and filter cleaning mechanisms prevent debris from building up on the filter. This allows more time between filter changes and helps maintain the proper amount of airflow through the dust collection system. It's important to correctly maintain the dust collection system. When the dust collection system is not working properly, dust is not effectively controlled. With regular use, the shroud can become excessively worn. Vacuum hoses can become clogged, filters can become overloaded, and dust collection bags will fill up. To help ensure the system is working correctly, the shroud must be intact and installed according to the manufacturer's instructions. The grinder must also be operated and maintained in accordance with the manufacturer's instructions to minimize dust emissions. Instructions often direct users to regularly check the dust collection system for signs of damage. Make sure the hose connecting the tool to the vacuum is intact and without kinks or tight bends that can reduce airflow and dust collection. Clean and replace filters as needed, not overfill the waste container, and follow a specified maintenance schedule. Be sure used filters and dust collection bags are handled in a manner that will minimize workers' exposure to silica dust. If the task is performed for 4 hours or less during a shift, the tool operator and workers assisting the operator must use respirators with an assigned protection factor of at least 10. If the task is performed for more than 4 hours, the tool operator and workers assisting the operator must use respirators with an assigned protection factor of at least 25. The appropriate respirator must be put on before beginning the task and must be worn the entire time the task is performed. Employers who perform tuck pointing must comply with OSHA's respiratory protection standard. Using a handheld grinder for tuck pointing indoors or in an enclosed area requires an exhaust method, such as a portable fan, as needed to minimize the accumulation of visible airborne dust. Be sure that any exhaust method chosen moves airborne dust away from workers and does not block an exit route. Employers who fully and properly implement the dust control methods specified in Table 1 are not required to measure the tool operator's exposure to respirable crystalline silica or the exposure of other workers assisting with the task. The respirable crystalline silica standard for construction also includes additional requirements to protect workers exposed to respirable crystalline silica. Many of these requirements apply whether employers are using a dust control method specified by OSHA in Table 1 or an alternative dust control method. More information on the standard's requirements to protect workers exposed to respirable crystalline silica, including information on specified exposure control methods for other common construction tasks, can be found at www.osha.gov/silica. For information about other OSHA health and safety standards, visit www.osha.gov or call OSHA at 1-800-321-OSHA.
Okay, we already learned a little about some engineered methods. One is spraying water. The other one is using a vacuum to absorb all the dust. And this one, isolation, is a third method that we can use to prevent silica dust or protect our workers against silica. It's isolation. So isolation separates the employer from the silica dust. This type of control is effective for operators in the cab, but does not protect employees working outside of the cab. So, by the way, if you can see in this picture, this worker is working with the door open, so it's actually not protected. The requirement is to close the door and turn on maybe the heating, cooling system you have inside, and you need to have a HEPA filter to filter the air that you are receiving, because you are producing a lot of silica dust and you don't want to breathe it. And also protect other workers, preventing them creating, maybe using an administrative method, creating a sort of warning sign around and only allowing authorized personnel to go inside of this area. So what administrative control methods that can we use to protect our workers? So we covered this area, engineering. Now we are going to talk about administrative control methods, and we have some control methods. For example, we were talking about limiting access to the workers in some areas, maybe using some warning signs and some signs preventing workers to go inside of an area in which we are going to produce a lot of crystalline silica dust. Rotation of workers. If you read table 1, you are going to realize there are some activities in which workers don't need to use a mask if they are working, but if they are working more than 4 hours, they have to. So in some cases, the employer can say, you know what, we're going to rotate our workers every 3 hours in a way in which they don't need to use masks at any time. There is something interesting about this rotation of workers. We have this new directive. I attached this new directive to your materials. This directive was published in June of this year, and they have a recommendation about this rotation of workers. The limit is 4 hours, okay? In some cases, you don't need to use a mask. But if you as employer are asking your workers to rotate when it is 3 hours and 59 minutes, for example, because you don't want to provide masks to your workers, OSHA doesn't like this idea, and they recommend everybody to have a sort of objective, or objective is to protect our workers, not only to fulfill the law. It is possible you can go to that limit, but OSHA doesn't recommend it, and they are not going to like it if you go to the limit. Okay, so you can rotate your workers maybe every 3 hours, and OSHA is going to be okay with this. But if not, they are going to start. Inspectors are humans, and they have this directive, and they can see you with a different perspective. For example, talking with the OSHA inspectors, they tell me whenever they arrive to a place in which everything is clean, good maintenance, everything is well organized, they immediately know that the safety in this area is good, and they are not going to have any big problem, because all the good maintenance, cleaning, no dust, no a good maintenance in the area is a good indication of a good level of safety. But if not, if everything is disorganized, everything is covered with dust, you will have a lack of maintenance. So they have this correlation. They say this place has a lot of safety problems, and they are going to be more. They are going to take more time doing the inspection. So there is this kind of correlation that they have in their minds. So a good cleaning and good maintenance is a good indication of good safety in an area also for them. So these are some administrative methods that they can use or we can use to protect our workers. And also there is this other method, the last one, the personal protective equipment. It is required in some cases. We have a sort of activity here to review all these methods that we can use to protect our workers. For example, elimination, we can remove the hazard. Sometimes if we decide to build the building using other materials, that materials having silica inside, replace the hazard. Sometimes we can use some tools that allow us to have this connection with the spray or water or the dust collector or vacuum. And sometimes these tools like a jackhammer or saw can be more expensive, but it is going to allow us to protect our workers and prevent us to produce this silica dust. Then engineer, isolate people from the hazard is another method, but we have the other methods, of course, using water, spraying water or a vacuum and isolate people from the hazard is an engineering method. Administrative control, change work practices. Okay, so we were talking about rotation workers, training our workers, limited the access to some areas using administrative methods, some signs, for example, and the PPE, the personal protective equipment. What kind of PPE do we need to use? We are going to learn from table 1 also what kind of PPE do we need to use in some circumstances. So personal protective equipment is the last resource. The use of respirators is needed when engineering control and work practice are not enough to control exposure down to a safe level. In some cases, it's mandatory also. In the table 1, we can follow all the administrative controls, all the engineer controls, but in some cases, we need to use some masks. It depends. It's a case-by-case situation. I want to share this video about this topic. Let's watch this video.
When you must wear a respirator to protect yourself against airborne contaminants in your workplace, it is very important to follow proper procedures for putting it on and taking it off. The process of putting on and taking off your respirator is also referred to as donning and doffing. Respirator manufacturers supply instructions on how to properly don and doff, put on and take off each respirator they produce. The manufacturer also supplies instructions on how to properly conduct a user seal check. A user seal check is a way to verify that the respirator has been properly positioned on your face to assure a proper seal. Sometimes workers confuse the term user seal check with the term fit test, which is different. A user seal check is not a substitute for a fit test, which is a more involved process that uses a test agent or instrument to verify the respirator's fit. A fit test must be performed before you wear a respirator for the first time and at least annually thereafter. A user seal check must be performed each time you put on a respirator to check that it has been donned correctly. Remember, always follow the respirator manufacturer's instructions for the specific respirator model that you are using. Here are some general instructions for properly donning and doffing and properly conducting a user seal check for the two most common types of respirators. Let's begin with general instructions for a disposable filtering facepiece respirator, which is often referred to as an N95 or a dust mask. Inspect the respirator, including the straps, for tears or damage. If you find any damage to the respirator, replace it. If your respirator comes out of its original container folded flat, open the folds fully, following the manufacturer's instructions. Using one hand, place the respirator on your face with the nose piece at your fingertips, allowing the headbands to hang freely. The nose piece should span and cover the bridge of your nose, and the respirator should cup your chin. Hold the top strap over your head, resting it high at the back of your head. Hold the bottom strap over your head and position it around your neck and below your ears. Be sure not to crisscross the straps. Make sure that your mouth and nose are covered by the respirator. If the nose piece has a metal nose piece or strip, use both hands to mold the nose strip to conform to the shape of your nose by pushing inward while moving your fingertips down along both sides of the nose piece. Next, conduct a user seal check. It's essential to follow the manufacturer's user seal check instructions because the manufacturer knows the best method for checking their respirator. Generally speaking, the manufacturer's instructions are based on covering the surface of the respirator, usually with your hands, so that air is prevented from passing through the filtering facepiece. A positive pressure seal check is performed by gently exhaling to see if the facepiece bulges slightly. For a negative pressure seal check, take a quick deep breath to see if the facepiece collapses slightly. During either test, if air leaks out between your face and the respirator's face seal, the respirator may not fit your face properly. One way that you can identify leakage is if you feel air blowing through the seal onto your face or eyes. If you feel leakage, readjust the fit of your respirator and check the seal again. If you cannot achieve a proper seal, you are not protected and should not enter a hazardous area. See your supervisor to determine what the problem may be. When you're finished wearing the respirator, carefully remove it without touching the exterior, because the exterior may be contaminated. Discard your respirator according to your company's procedures. Now let's explore the general instructions for properly donning and doffing and properly conducting a user seal check for a half face piece elastomeric respirator, sometimes referred to as a half mask. Remember, these are just general instructions. You should always follow the manufacturer's instructions for the specific respirator model that you are using. To begin, inspect the respirator, including the straps, valves, and gaskets, for loose, missing, or damaged parts. If you find any damage to the respirator, repair or replace it. Then pull the bottom strap over your head. Place the respirator facepiece under your chin and over your nose, with the narrow part of the facepiece over your nose. Pull the head harness over the crown of your head and adjust its placement until it is stable but comfortable. Be sure that the neck strap is flat and smooth against the back of your neck. Adjust the neck strap, but be careful not to over-tighten the respirator to your face. Next, perform a positive pressure user seal check. Place the palm of your hand over the exhalation valve outlet. Do not push so hard that you distort the natural shape of the facepiece. Exhale gently and hold your breath to create and maintain a slight positive pressure inside the facepiece. If the facepiece bulges slightly and no air leaks are detected between your face and the facepiece, a proper fit has been achieved. If, on the other hand, you detect a face seal leakage, reposition the facepiece and readjust the straps, and then retest. If you cannot achieve a proper seal, you are not protected and should not enter a hazardous area. See your supervisor to determine what the problem may be. Next, perform the negative pressure seal check. Cover the respirator cartridges or filters with the palms of your hands. Inhale gently. If you feel the face piece collapse slightly and pull closer to your face with no leaks between the face and face piece, a proper seal has been made. If you detect face seal air leakage, reposition the respirator on your face and readjust the straps, then recheck. If you cannot achieve a proper seal, you are not protected and should not enter a hazardous area. See your supervisor to determine what the problem may be. When you have finished wearing the respirator, carefully remove it by loosening the straps and taking it off without touching the cartridges or filters, because they may be contaminated. Follow your company's procedures for maintenance of the respirator, including proper cleaning and disinfecting and storage. Remember, respirators must be used in the context of a comprehensive respiratory protection program, according to OSHA Standard 29 CFR 1910.134. For additional information on respiratory protection in the workplace, consult this website.
So we have learned in this module all the methods, control methods that we can use to protect our workers. And tomorrow we are going to continue with this presentation, learning how can we use table 1 in combination with all these methods that we were using. So that is it for today. Do we have any question, Paula?
Yes, we do have one that came in. It's, can you use the handheld concrete saw that has no integrated water delivery system or vacuum?
Yes, you can use a spray method. So you can use somebody else spraying water on this area, for example. Maybe they don't have attached the spray system or the hose or the vacuum system, but you can have somebody else providing you, for example, water on the point of contact, spraying some water with a pump, with a water pump. So you will need another worker helping you to do the task. That's an alternative. Just in case, OSHA has published several videos related with this silica protection, and related very much to the table 1. OSHA has published a lot of fact sheets too, specifically for each situation on table 1. We have 18 different situations in table 1, 18 different activities in table 1, and each activity has a fact sheet published by OSHA. You can visit the OSHA webpage and get this information, or visit YouTube, or the OSHA has a video library too. Inside you can visit it and go to these sections, and you're going to find a lot of these videos too in this OSHA webpage. But talking again about this question, that's an alternative. You can have another worker with a water pump spraying some water in the point of contact, and you are going to be okay according to the law. Any other
There are no
questions?
other questions. No.
So we can proceed with the poll, and thank you everybody for your time, your patience, and we can continue tomorrow. Thank you, Paula.
Okay, polls up. Go ahead and hit the escape key if you were in full screen to be able to vote. According to OSHA, what is not a measure used to protect against silica? Please select one answer.
What is not a method?
All right, we have about 80% who voted. So I'm going to close the poll. All right, so Robinson, we have 23% who chose isolate the operator in the cabin with a dust filter, 5% who chose using water to contain the expansion in the air, 23% chose use vacuum cleaner to contain its expansion in the air, 5% said wear a mask or breathing apparatus, and 45% chose none of the above.
Yeah, the last one is the right answer, because all the others are methods authorized by OSHA to prevent silica the absorption of silica, crystalline silica by the body. So we were talking about all these things. Before, you can use a spray water, you can use a vacuum, you can isolate the workers, you can provide masks. It depends on the circumstances, but all these methods are authorized by OSHA. It depends on the circumstances. We are going to learn a little more about it tomorrow. Thank you, Paula.
All right, thank you. We'll see you all back tomorrow.
Thank you. Bye-bye.
Bye-bye.